Ugh. I feel so. Okay. We have a lot to go through. Yeah. All right. Yeah. Make it 2. Yes. Should I write it down? Yes. Okay. So the quadratic formula, if you have a formula that is a x squared plus bx plus c equals 0, then you would take the first coefficients and plug it into this formula. And that would be your x's for your quadratic here. If you have a circle, so this would be the equation of a circle. The radius of the circle will be r. The center point of the circle in the x coordinate is going to be h, and the y coordinate is going to be k. I don't know if we need any more, so I guess we could update this as we go on. Find the domain of the rational expression. Remember, the domain is the x coordinate, so it's saying find all x coordinates where this rational expression exists. Therefore, I mean, that's what it is, right? What you can't do for all functions is you cannot divide by 0. So you got to find when this denominator is equal to 0. And when is it equal to 0? Well, it has to equal to 0 when it equals 5. So, it'd be B. Same thing for this one. When is the denominator equal to 0? If x is equal to 0, 0 times 0 equals 0. So x has to be equal to 0. But also, if x equals 1, 1 minus 1 is 0. 0 times anything is 0. So it's either 0 or 1, which is D. Solve the equation. Identify the equation as an identity, inconsistent equation, or conditional equation. Identity means that anything you plug in for x, or I guess in this case m, the equation is true. Inconsistent means anything I plug in, nothing works. And conditional means I have to plug in one thing and the equation holds true. So let's solve it for this. 28m plus 16 equals 16m minus 92. Right, I just distribute this 4 out. Yeah. And then combine like terms, 28 minus 16 is 12m. Negative 92 minus 16 is negative 108. Negative 108 divided by 12 is negative 9. So there's only one solution where this equation holds true, and that's negative 9. So therefore, it is conditional. Solve the absolute value equation. Remember, anything in the absolute value sign becomes positive. So if I had negative 100, this just becomes 100. If I had negative 23 plus 5, that equals, what does that equal? 18, right? Negative 18, which would just equal positive 18. So, that being said, anything I plug into here has to be negative 5 or positive 5. Because if I have a negative 5 in here, it just becomes 5. And if I have a positive 5 in here, well, that also just becomes 5. So, if I plug in, let's say, a 14 here, 14 minus 9 is negative 5. Negative 5 in an absolute value sign is just 5, so that checks out. And if I plug in 4 here, oh wait, I don't think I said that right. 14 minus 9 is positive 5. Positive 5 in an absolute value sign is positive 5 in an absolute value sign is just 5, so that checks out. 4 minus 9 is negative 5. Negative 5 in absolute value sign is just 5, so that checks out. So your answer is D here. X plus 1 equals negative 6.4. So your first guess would be negative 7.1 or 7.4. Negative 7.4 plus 1 is negative 6.4. Negative 6.4 in an absolute value sign becomes 6.4. So that doesn't work out. Okay. This one doesn't work out. 4,096, of course, doesn't work out. And negative 6.4 plus 1 is negative 5.4. Negative 5.4 in the absolute value sign is just 5.4, so that doesn't work out. So then your answer has to be A. T minus 7, it would just be 7. Find the center and radius of a circle. Remember that the formula is x minus h squared plus y minus k squared equals r squared. So our h is going to be 3, our k is going to be 0, and our r is going to be 6, right? And so our center is going to be 3, our center x coordinate is going to be 3, our center y coordinate is going to be 0, and our radius is going to be 6. Right, because 6 squared is 36. Y minus 0 is just y squared. Or y minus 0 squared is just y squared. And then x minus 3 is the same thing if I just plug in 3 into h. Oh, that's just my hair. If this was, let's say, x plus 3, then h would have to equal negative 3, because if I plug in a negative 3 into here, that becomes x minus a negative 3, which of course is positive, which is what I have here. So if it was x plus 3, then h would be negative 3, and if it's x minus 3, then h is just positive 3. Shoot, which one would... I think it should be B. B. Oh, that was just one page. Okay. Similarly, our h is going to be negative 2, our y is going to be, or our h is going to be positive 2, our y is going to be negative 5, and our radius is 5. So 2, negative 5, 5, C. So slope-intercept form is y equals mx plus b. I suppose I could have wrote that. The slope here is m, and the y-intercept is b. So just solve this equation for y, and then you get it. So 6x minus 2y equals 3. Solving for y, I bring the 6 over here, so it becomes negative 2y equals negative 6x plus 3. Divide both sides by negative 2, so it becomes y equals negative 6x over negative 2 plus 3 over negative 2, which of course is 3x minus 3 halves. This is our m, and this is our b. So which one fits that description? Well, the only one that actually works as our slope-intercept form is c, but also this is m, and this is our y-intercept. So that's the one works. A ladder resting against the wall. Top ladder touches the wall at a height of 6 feet. I guess I'll draw the ladder, right? And this is our brick wall. That looks like a ladder, so I'll just draw like. There you go. I should use red, whatever. And then this is 6 feet right here. Find the length of the ladder, or the length of the ladder is going to be c. If the length, again c, is 2 more feet, so the length of the ladder is 2 more feet than the distance from the wall. So let's call this b. So it's saying if the length c is 2 more feet than the distance of the wall, which we're saying is b, then if we were to say b is equal to 10, that means the length would be 12, right? Because that's 2 more. If the distance from the wall is equal to 8, then c would equal 10 because that's 2 more. Using that train of thought, right, then we can make the equation c minus 2 equals b, right? Because if I were to plug in 8 into here, that means since c is 2 more, so like this equals 8, c is 2 more, that's 10, so 10 minus 2 equals 8. So this equation holds true for everything that we plug in for b or c, because c should be 2 more than b, right? So if we want to do one more, if b was like 20, that means c would be 22. 22 minus 2 is equal to 20, so this equation checks out. All right, next part. So we know the hypotenuse of a right triangle is a squared plus b squared equals c squared. We know a, which we'll call just this side right here, and we don't know b or c, but we're looking for c in the problem. So it's better to substitute this b with this equation right here and then solve for c. So it'd be 6 squared plus c minus 2 squared equals c squared. And then you could solve for c and you get 10 feet. But I'll just do it right now, I guess. This equals c squared minus 4c plus 4 equals c squared. Bring all the c to one side and bring all the numbers by themselves to one side. So we'll bring the c squared over. Subtract c squared from both sides. This cancels out. This cancels out. Bring this 4c over. Add 4c to both sides. This cancels out. This becomes plus 4c. And then 6 squared plus 4 is 40. So 40 equals 4c. That means c equals 10, which is what we got right here. I'll just do a lot is in the so like a parking lot is in the shape of a right triangle. The short, or is it parking? Well, it doesn't matter. Is in the shape of a right triangle. So hypotenuse already. Call this C, or I'll draw it to like maybe scale. So we do. Okay. The parking lot is in shape of a right triangle. The shorter leg measures 180 meters. So let's call this A, and equals 180 meters. The hypotenuse is 60 meters longer than the length of the longer leg. So same thing again. Whatever I plug in, or whatever I get for B, the hypotenuse C is going to be 60 meters longer. So if B equaled 100, that means C would equal 160. Right? So using that logic, we could make another equation with both of them. So we'll do a similar one. C minus 60 equals B, right? Because if I plug this into here and this into here, this is true. And this is true for any B or C we get. So, what are we looking for? How long is the longer leg? So we're looking for B in this instance. So let's use this equation to solve for B right now. So it's going to be B equals, oh, wait, no. Solve for C for this one. C equals B plus 60. Because we're going to be plugging this into the C and then solve for B, because that's what we want. Okay, back with this one. A squared plus B squared equals C squared. We know A is 180. We know we want to find B. We don't know C, but we do know this. So we can plug that in for C. B plus 60. And then same thing we just solved for B. So we could do 180 squared plus B squared equals B squared plus 120B B plus 60 squared. Bring all the b's to one side and all the numbers to the other. So subtract b from both sides. This cancels out because this cancels out. Subtract subtract 60 squared from both sides. So this cancels out, and this becomes negative 60 squared here. So let me write that out. 180 squared minus 60 squared equals 120b. Divide by 120 on both sides. This cancels out. This becomes 120. So b equals 180 squared minus 60 squared over 120, which I think is 240. I don't remember. Pretty sure. Use the square root property to find all real or imaginary solutions for the equation. This one you could solve either by doing x plus 3 equals 64. Distribute that out, that becomes x squared plus 6x plus 9 equals 64. X squared plus 6x plus 9 minus 64 equals 0. And then you could factor this out and get the answers from this, right? Wait, I guess if you want to see that, that becomes negative 55. Oh, wait, nope. Do this. And it become, what multiplies to negative 55, add up to positive 6. That becomes x plus 11, x minus 5. Therefore, x equals negative 11 or positive 5, which is this one. Or you could just solve for x here without having to factor it. So x plus 3 squared equals 64. Getting rid of the square root, or the exponent becomes the square root. X plus 3 equals plus or minus 8, because square root of 64 is 8. And if you do negative 8 times negative 8, you get positive 64. And if you do positive 8 times positive 8, you get negative, or you get positive 64 again. So it's going to be plus or minus 8 as the answer for that. Then it's going to be x equals plus or minus 8 minus 3, right? And then if you solve that for positive 8, you get positive 8 minus 3, which is positive 5. Or if you make it negative 8, it becomes negative 8 minus 3, which is negative 11, which is the same answer we got here and here. So you could do either one. This one, however, you have to do by factoring. You can't do this method. Right, let me use red to make it pop out more. You can't use this method, so you have to use this method for the second one. So y squared plus 5y equals 24. Y squared plus 5y equals 24. You subtract 24 from both sides, so y squared plus 5y minus 24 equals 0. What adds up to, or what multiplies the negative 24 adds up to 5? That is, I mean, you can see here that it's 8 and 3. So it's going to be positive 8 and negative 3, right? Because positive 8 times negative 3 is negative 24. 8 minus 3 is positive 5. So that means x equals negative 8 and positive 3. Be this one. There is a trick to solve these that I don't recall how to do. So what you can do is just plug into the quadratic formula and solve from there. The only problem is that b is going to be 23. 23 squared is a big number, so that might not be the best option, but I can't think of the answer. So, I mean, if I recall, the answer is this, but I could just solve it until you could just plug into a calculator. So this is our A, this is our B, and this is our C. Remember that the quadratic formula is minus negative b squared over 4. Right? So in this case, our b is going to be 5, so it's going to be negative 5 plus or minus b squared, which is 25, minus 4 times... Oh, wait. I'm using the wrong number. Hold on. Oh, no. Okay. This is our b. So it's going to be negative 23. B squared is 23 squared. Minus 4 times 5 times negative 10 over 2 times 5. I don't have a calculator hand. I'm not doing this by hand. But you could solve...
Benny boy?
Mande.
You left your wallet by the door. I'm going to put it in your room, okay?
By the door?
Yeah.
What do you mean by that?
So the entrance to the house in the front.
Oh, right.
You want it in your bedroom or on the kitchen table?
Just leave it on the kitchen table, please. Thank you. If I recall, this equals... Whatever the square root equals is 27. If I recall correctly. This is 10. So it's negative 23 plus or minus 27 over 10. Which negative 23 plus 27 is 5 over 10. Nope, 4 over 10. Oops. Which is, of course, 2/5. And then that's one route, so I'm going to put an arrow here. Another way is negative 23 minus 27, which is 50. 50 over 10 is 5, so it's 5 right here. Or negative 50. Negative 50 over 10 is 5, so 2/5, negative 5. So B. Find all real solutions to the equation. Oh man, I barely made a dent. I'm not even a fourth through. Okay. X to the negative 2/3 equals 16. First things first, let's just isolate the x. So when you're getting rid of an exponent, you just do the reciprocal and put it on the other side, right? So if I had like a square here, then if I want to move it over, I just take the square root. Because if you did not know, a square root is the same thing as saying 16 to the 1/2, right? Which is happening. If I get rid of this, it becomes the reciprocal, which is 1/2. But most people just write that as the square root. So that's what that is. So in the same vein, we take the reciprocal of this and apply it to this one. And if it was like plus x, a bigger number, then you would apply it to the whole thing right here. Okay. So that becomes x equals 16 to the negative 3/2. Okay, so what's next? When you have a negative exponent, it doesn't make this number negative, but it turns it, or you take the reciprocal of the number with the exponent, right? So if I had x to the negative 3, that's actually saying 1 over x cubed. So this becomes x equals 1 over 16 to the, nope, not negative, 3/2. All right. Now from here, you could probably just plug in your calculator, see what you get. But if you want to do it by hand, I mean, if you have a calculator by hand, then you could do 16 cubed, whatever that number is, and then take the square root of it. But I don't, so I might want to do 16 root, which is equal to plus or minus 4, and then cube it, which is plus or minus 64. So it's going to be 1 over plus or minus 64. Right? I mean, at this point, you might as well just plug in the calculator. But if you don't have one, then I would approach doing the easier number first, which is doing the square root first of 16, which is plus or minus 4, and then taking that to a cube, right? So this is going to be plus or minus 4 cubed, essentially, which is, of course, plus or minus 64. And then that's all over 1, so again, you get that number. X minus 4 to negative 1/4 equals 1/3. Again, if you want to get rid of this, do the reciprocal, so you get x minus 4. Get rid of it, so x minus 4, so 4 equals 1/3 to the negative 4th. Oh, I don't want that one. which of course you distribute this negative to, or not negative, you distribute the exponent to each value in the parentheses, so it becomes x minus 4 equals 1 to the negative fourth, 3 to the negative fourth, which of course 1 to anything is just going to be 1, so it becomes x minus 4 equals 1 over 3 to the negative fourth. And then 3 to the negative exponent is going to be the reciprocal. And the reciprocal of 1/3 is equal to 3. So you can write this as x minus 4 equals 3 to the fourth. 3 to the fourth is 3 times 3, 9. 3 times 3, 9. So 9 times 9 is 81. So x minus 4 equals 81. X equals 85. This one is a bit tricky because one of them has a square root, and there's an x on this side and there's an x on this side. If the x was isolated, like in this case, there's only an x on this. There's only one x on this side, and well, there's one x on this side and it's an alone. Then you could probably solve it using this method. But since there's two of them and there's one on either side, then you're just gonna have to use a quadratic and factor it. So let's solve for x. Let's make it a square first. So this becomes get rid of the square root, so it becomes x plus 13. Right? But that doesn't make it that much simpler, so then let's turn this into a proper looking quadratic. So it's going to be x plus 13 equals x minus 7. X minus 7. Distribute that out. That becomes x plus 13 equals x squared minus 14x plus 49. Set this equal to 0, so bring all the terms to one side. That is going to be x squared minus 15x. What is that? 36. And that, of course, equals 0. What multiplies a positive 36 and adds up to negative 15? 3 and 12, right? Yes. So negative 3, negative 12. Fuck. Right? Negative 3 times negative 12 is positive 36. Negative 3 plus negative 12 is negative 15, so that works out. Therefore, x equals positive 3 and positive 12, which is that one. Determine whether the equation defines y as a function of x. What am I looking for here? I don't remember what this means. So we'll just skip that for now. All right. I'll write in green. Skip. Lovely. Okay. Use the vertical line test to determine whether y is a function of x. Remember, vertical line test, if I put a line anywhere through my graph and it hits two places, it is not a function. If it only hits one, it is. And as you can see here, it hits twice, so it's not. No. Anywhere I put one vertical line, it only crosses one point. So like here, here crosses one point. Therefore, it is, and that's all of that. Okay, cool. Determine whether the relation is a function. Poop. I don't remember what this means either. This one you can't have any repeating x or y values. So that for -1 you have 3, for 1 you have 7, for 6 you have 8, for 8 or 8 in the x direction you have 2. This is 8 in the y. 11 you have 7. Oh, because it's like this. So, okay, you could have repeating y values, but not repeating x values, right? Because here you see there's a 7 here, and there's a 7 here in the y direction, but that's fine. But here, you have an x3 and an x3 here, so it is not. So you could have repeating y values, just not repeating x values. So, no, yes. I think that's what that means. I don't specifically recall. Find g of a plus 1 when g of x is 5x plus 3. This one, all you're doing, you have of g of x, and they're saying plug this a plus 1 into this x, and then solve. So you're taking this a plus 1 and plugging it into here. So it's going to be 5a plus 1 plus 3. Distribute the 5, it becomes 5a plus 1, or 5a plus 5 plus 3, which is 5a plus 8. If f of x equals -3x squared minus 2x minus 2, find f of -3. Where are my sandals? Okay. Again, similarly, we have an f of x and we have an f of -3. So all this is saying is plug in -3 into each x and solve. So I'm just going to, you know what? No, I won't. That's bad. So -3 squared is going to be 9 times -3 minus 2 times -3. I guess I could have just done that one. Minus 2. -3 times 9 is -27. -2 times -3 is going to be +6. Or you could do 2 times -3 is -6, which minus, plus, +6. But, I mean, it's the same thing. It don't matter. So, +6 minus 2. -29 plus 6 is -23. This one. Find the domain and range. This one is the graph one, or the one you kind of have to conceptualize. Yes, I mean, you can see, yeah, right here, but domain is the x direction, right? And the range is the y. So for these questions, we want to avoid having an imaginary number here. Imaginary is anything that's a negative under the square root. So I could have a 0 under the square root, but anything below that is bad in this case. So how do we get anything below 0 here? It has to be over -9, right? Because 9 plus a -9 here, that's 0, which is fine. But anything lower than -9, like -10, that's going to be bad. So our domain already tells us that it's going to be from -9 to positive infinity, right? Because if I choose any number in positive infinity like 3, 9 plus 3 is fine because it's not negative. Or if I choose a billion, 9 plus a billion, still positive. But anything past -9, like let's say again, -20, 9 plus a -20 is -11, which gives us imaginary, so that's bad. So our range is from -9 all the way to positive infinity. That is the only one that has it, so That's all you have to worry about right there. This one also kind of has it, but again, if you're plugging into X, that's our range. So, or no, if you're plugging into X, that's our domain. So the only one with D as with the -9 is this one. Okay. Ooh, we're getting a little speedy now. Graph the function. Did they not? Oh, this is your writing. Okay. Well, I guess I'll just draw over it. So, this is a piecewise function. And so let's look at it first. From f of x, when x is greater than or equal to 1, right? So from when x is greater than or equal to 1, so this point right here, f of x, or the line, right, is equal to 4. Okay, so that means it's just going to be this straight line, which you already wrote down. Because this is saying y, get f of x is a weird way of saying y, and this is equal to 4, and the y value is right here at 4, so it's going to be a straight line. And then since it's touching, it's going to be a black whole dot right here. All right. Then we're saying when x is less than 1, right, not equal to 1, less than 1, so immediately it's going to be a circle dot without it filled out. So I'm going to use red now. When x is less than 1, then the slope y is going to equal to -2 minus x. Which, if you want that written a little different in slope-intercept form, you can just flop them around. X -2 minus 2. Now it's in proper-looking slope-intercept form. So our slope is -1. Our y-intercept is -2. So we know it's going to be at -2. Our slope, or our y-intercept. This is the y-intercept right here, and it's going to be at -2. So might as well put that dot there. And then we know the line is has a -1 slope, so it's going to be going down 1 over 1, down 1 over 1. So immediately you can just do that on your little graph here. It goes down 1 over 1. And remember, since it's x less than 1, it's going to be a circle dot here. And then you could draw it over, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now you don't have to keep going, but I think you see the vision here. Actually, how do I get rid of that? I don't want that there anymore. No, I want that. Okay. Okay. So this is how our line's going to look. Ignore this blue line right here. But it's going to, and then I might as well just draw like an arrow going this way. So which one matches that one? It's going to be B. This one also matches similarly, but it has the circle dot right here and the whole dot right here, which if it has the equal symbol right below the inequality sign, then it's going to be a whole dot. Oh, another one. And you already drew it, but I guess we could just confirm. No. Okay. Excuse me. So x is greater than 0. Our function is going to be x minus 2. So that means our slope is going to be 1 and our y-intercept is going to be -2. So when x is greater than 0, so this is going to be our line, because at this line it's going to be 0. Our y-intercept is -2, so we could just put a circle here already. And then we know our slope is just 1, so it's going to be up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's going to be that straight line here. And then when x is less than or equal to 0, it's going to be 5, which again you can see right here that you already did it. It's going to be a straight line that way. B, right? Yes. And then this is the only one possible one it could be, because it has this 5 one here, and it's the only one with the positive slope going upward here. Determine the intervals on which the function increases, decreases constant. For these, you're going to be reading from left to right. And so when the function's decreasing, it's going downward. When it's constant, it's flat. And when it's increasing, it's going up. So just based off... Wait, what? Oh, there's no multiple choice. I just got to say it. Okay, so from... What point is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, they're in by tens. So from negative infinity to 1, 2, 3, 4, -4, it's decreasing. From -4 to 4, it's constant. And from 4 to infinity, it's increasing. Write out the full letters, or the full words, but you know, I'm not doing that. I'm not sure if it specifies using brackets or. I guess I could do this, right? There's curly, bracket, 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 bracket. Because the bracket means it touches the point, while the curly means it approaches, never touches, right? And then you approach infinity, you don't touch it, but in here you can see that it's touching 0.4, or -4 and 0.4. So that's why I use the brackets for some of them. For this one, it's going to be going, remember, whole dot here and circle dot here. So it's going to be from -5 to -2, and it's a circle dot, so you use the parentheses. And this one's constant. From, do I want to do that? Yeah, I'll do that, whatever. From -2 to 0, it's increasing, right? Because they have two whole dots. From 1 to 3, so I'll do it right here, it's decreasing. And then from 3 to 5, it's increasing. There you go. Determine whether the function even, odd, or neither. I forgot the rules for that one. What page is this? Should I do another skip? Okay, I'm going to skip this, but I'll come back. Because I forgot. Oh, there's still so much. Poop. Graph the pair of function on the same plane. Use a dashed line for g of x. Okay. Okay. So, immediately you could get rid of B, because the B graph is an absolute value graph and not a parabola. You can immediately get rid of A too, because if this is f of x, this would be a negative function, which there's no... If it was a negative x squared in front, then it might be this one. But since it's not negative x squared in front, you can immediately get rid of A as well. So it's either C or D, which, I mean, you see it's this one. But so x squared, this one's f of x, and g of x is x squared minus 3. Okay. It might be better if where's Desmos? So if I have an x squared, I'm going to show the answer anyway, but... So what a number without a variable does is it shifts the graph upward or downward. So if I said plus 20, it's going to go upward 20, right? You can see this is the vertex point right here at 20, and f of x is at 0 because it's plus nothing, right? So any number that does that is going to shift it upward or downward. So if I put minus 3 again, it's going to shift it down minus 3. So the vertex is at 0 minus 3. If I do plus 2x, why did it go down? Whatever. The middle number with the smaller variable, right? So not x squared, but x, shifts it to the left or right. Apparently it shifts it down a bit too, but I thought it just shifts it left or right. But yeah. And then a number in the front shrinks or expands the graph. So if we put in front 1/5, it's going to shrink it or make it fatter, I guess. And if I put times 6 in the front, it's going to make it skinnier or taller, which there you go. So this is the red is our original, the blue is our new one. So that being said, this one has no variable in the back, so the only thing it's doing is moving up or down, and it's moving it downward because it's negative, and so the only one that shows it moving downward is D. This one shows it moving to the left, which you would need like a x squared plus 2x plus 1 for it to be that one. Something like that. So it's D. Oh. So, is there any I could get rid of immediately? I could get rid of D, because this isn't going to be a negative number or a negative graph, because you would need a negative sign in front of the graph. So immediately D is out of the picture. So is it A, B, or C? One thing you could certainly do is okay, well, first of all, just ignore the whole line or the black line completely, because they're the same on each graph, because that's what this is. We're focusing on the dotted lines for each graph. So with the dotted lines are this one. So what we could do is look on the graph, and we could just pick an x point and see where it lands on this graph, right? So x minus 5, let's say we want it at, let's say 5, right? X minus 5 is 0. Absolute value is 0, 0. So where does that stay true? So x of, I said 5, right? So 5 would be right here. The graph shows like 9.5 for this one, which isn't 0. So it can't be this one. Again, 5 right here. It should be at y equals 0, which this one is 0, so this one's good. And this one at 0, so x equals 5 should be y equals 0, which is true. So it's either A or B. Let's pick a different number. Let's choose 0. So 0 minus 5 is negative 5. Absolute value of negative 5 is 5. So if we plug in 0 for x, our y value for g of x should equal 5. So for this one, if I plug in 0 at x, so x of 0 is here, this one equals negative 5. That's not negative 5, so we can immediately cross this one out. If I plug in 0 for here, at x equals 0, y is at 5 here, which is that. So this is B. You can also do the same thing for this one. You can plug in a number and see which one fits the graph. But I think this one's a lot easier to just kind of visualize, while this one, this one you might just want to plug and chug. Halfway there. Okay. The graph of y equals absolute value x is vertically stretched by a factor of 6.9. The graph is reflected across the x-axis. Finally, the graph is shifted 0.77 units downward. Oh, I see. Okay. So, same thing for the parabola. Remember that anything in front of a number multiplying with the variable stretches or shrinks the line. The graph is reflected across the x-axis, so that means it was turned. So okay. Let's just do it here, right? Do I have an absolute value here? Yeah. I mean, we could just make the thing. So, what does it say? The graph is vertically stretched by a factor of 6.9. So it's stretched by a factor of 6.9. So it's going to be multiplied by 6.9, right? Because anything multiplying with the variable is going to stretch or shrink. It shrinks it if it's a number below 1. It stretches it if it's a number above 1, right? So a number like 1/2, that's 0.5. 0.5 shrinks the line. A number like 2, which is above 1, stretches the line. 6.9 is above 1, so it stretches. Okay, then it says it is reflected across the x-axis. That means you multiply this by a negative, right? That's all that does. All right, if I had an x squared, if I want to reflect that across the x-axis, I just multiply this entire thing by negative 1. There you go. Okay. Then it is shifted 0.77 units downward. So downward is negative, and 0.77 is this vertex right here. So, I just showed you how to write it. This is what happens to it, right? And so it'd be that, right? Stretch or shrink, you're multiplying. Flipping across the x-axis, you're multiplying by negative, and then shifting upward is positive, shifting downward is negative, so you're subtracting 0.77 and not adding 0.77, so it'd be that one. And then originally it's y equals x, so that's where, you don't add to the absolute value, you keep it outside of it. Find f over g of negative 5. This one is all it's saying is f of negative 5 over g of -5, which of course you're replacing all the x's in both equation with -5. So I guess we could just, okay, we could solve for f of -5 first. So this is going to be, I'll do it in blue and then I'll write in red. So 5, -5 minus 2. That's going to be -25 minus 2, which is -27. 4. -5 times -5 is 25. 4 times 25 is 100. It's going to be 102 because of this 2. And then 14 times 5 is 70. 14 times -5 is -70. So this is going to be 32. And then, I mean, that's it. -27 over 32. Given f of x equals 5x minus 4, g of x that, find f of x plus g of x. So again, it's just saying f of x plus g of x. You're not plugging anything in, you're just solving, whoa, what the hell? You're just combining like terms. So we could do, that's f of x plus g of x. Combine, so it's going to be f of x minus 4 minus 7x plus 10. 5x minus 7x is -2x. -4 plus 10 is plus 6. So this is our answer, which is this one. Find the requested composition of functions given f of x is 5x plus 13, g of x is 5x minus 1. Do the multiplication. So this one's saying f of x times g of x distribute, so it's going to be 25x squared minus 5x plus 65x minus 13. You can't add this one with anything. -5x plus 65x is just 60x minus 13. Huh? What did I do wrong? Say what? What the fuck? Find the requested composition of the. Where is it? No, it's not that. Oh. Okay, I see. Man, who writes it like this? I mean. Oh, oops. Okay. They want, I wrote the wrong thing. They want f of g of x. I don't know why they write it like this or like this. I don't like that, but whatever. So they're saying plug in 5x minus 1 and replace it with this x. That's what they're saying. So it's going to be 5x minus 1 plus 13, which is 25x x minus 5 plus 13. Negative 5 plus 13 is 8. Which is that one. I don't like this formatting, but whatever. Again, f of g of x is just put in g of x for x in whatever there. If it was g, oh, I keep messing up the g of f of x, then you're plugging whatever f of x is into this x is for g. Okay. Okay, this one is g of f of x. So we're putting anything, whatever f of x is, into this x. So 6 negative 4x plus 8 plus 7 negative 24x plus 48 plus 7. 48 plus 7 is 55, so it's going to be negative 24x plus 55. Find the inverse of the function. The inverse is just the reciprocal. So 8x minus 6 is I guess if I would that be it? Why does that seem wrong to me? What number is that? 41? No, that's right. If I take, okay, well, either way, if I just do this, 8 minus 6, the inverse is you're making it the reciprocal or to the negative 1. Honestly, you could just do this. Why is it x plus 6 over 8, though? Maybe I'm incorrect. Let's do it this way. So it would be, let's just set it equal to 0, see what happens. No, but it says plus. What? I might be tweaking. Alright, this is another one of them skips. I'll come back to this. On the same axis, draw the... Fuck. Screw you. What am I looking at here? Are these drawn or are these... What? The graph of the function f is given on the same axis. Sketch the graph of f of number 1. Okay, so this one is that. Oh, they give you the perforated line too. All right. Well, for the inverse function, they give you. I'm gonna keep it green. Why not? They give you this y equals x line, and then they also give you this f of x. So the inverse of that is just gonna be flipped over this green line over here. So if you mirror the green, this blue line over the green line, I mean you already drew it out, but you get this kind of red line here. Which one matches that one? It's going to be this one. The inverse always mirrors it. You kind of see that, like, here's kind of like a mirror. Here's kind of a mirror. Oh, no, this one's not a mirror. This one, I don't even know what this is. So you can cross this one out because it doesn't mirror it. This one mirrors it about the x-axis, but you want to mirror it about this line they give you. This one mirrors it about this line, but a mirror would kind of just do that, right? This one completely flips it the other way, right? So you want this one where it just mirrors it across, like, again, a mirror. I don't I don't know what to say here. This one rotates this completely by 180 degrees, right? So if I were to rotate this line, it becomes this one, which isn't mirroring, it's just rotating. Identify the vertex of the parabola. The vertex is this point on a parabola, the peak or the valley of the parabola. Well, I forgot the formula for it. I'll write it after. I'll come back to it. Skipped. What am I writing? Find all real and imaginary zeros for the polynomial function. This one. Oh, there's still so much. This one I think you could separate by x cubed plus 2x squared plus 25x plus 50. This is still the same function. And then you could factor out a 2x squared from this one, so it becomes 2x squared. X plus 1. Oh, wait, no. Factor out an x squared. Yeah. What am I talking about? X squared. So it becomes x plus 2. Right? Because if I distribute that, it becomes this. And then plus, I could factor out a 25 from both of these. So that becomes x plus 2. And then we have x plus 2 here, x plus 2 here, so we could factor them both out. So you get x plus 2, x squared plus 25. Right? Because if I distribute this x plus 2, it becomes the same thing as the top thing. So we have one factor here. Now we can factor this one a lot easier. We could set this one equal to 0. So let's just separate it. So x squared plus 25 equals 0. X squared equals negative 25. X equals root negative 25. X equals imaginary root 25, which of course is x equals plus or minus 5 imaginary. So that means our factors are going to be x equals negative 2. Nope. And x equals plus or minus 5i. So it's going to be x equals negative 2, 5i, negative 5i. Those are our factors. Use synthetic division to find the function value. I don't remember that. I'm not even going to pretend I remember that. Whatever, skip. Find the domain and state the domain of the rational function. Again, can't be negative on bottom. So we just factored this one when is equal to 0. X squared minus 16, that's going to be x equals plus or minus 4. Right? So this function exists from anything that is below negative 4, right? Because it can't be negative 4 and it can't be 4. That's what it's saying. So anything below negative 4 is fine. Anything in between negative 4 and 4 is fine. And anything above 4 is fine. So then we could write our domain for that. So anything below negative 4 is fine. And it can't be negative 4, so we're using a bracket. That's good. Anything in between -4 and 4 is fine. So -4, comma 4. And anything higher than 4 is fine as well. So 4 to positive infinity, which is the only one here. And then you would use the union signs because they mean and. B just wouldn't be right because it's not 2. This one uses -4, not right. Let me get rid of this. This one wouldn't be right because it's saying from negative infinity. Oh, this one doesn't even have -4 in front. It wouldn't be right either. This is the only one that has -4 and a 4. Oh, so I guess you could do it by that way. I got 1, 2, 3, 4, 5, 6, 7. 7 plus the ones I skipped. Oh! Right. I took a bad picture. F of x equals 4 to the x. You kind of just visualize this. So let's say x equals 0. Anything to a 0 exponent just equals 1. So 4 to 0 equals 1. If x equals 1, 4 to the 1 is just 4. If x equals 2, it's going to be 16. If x equals 3, it's going to be 64. So you can see, like, if you were to draw this on a line, it's going to be flat, and then it's going to shoot up, right? Because at x equals 1, it's going to be 4. X equals 2, it's going to be 16. And x equals 3, it's going to be 64. Right? And these are the y values on the side. So it's going to just keep increasing crazy and crazy higher. Which graph has that exponential rise upward? Well, this one's negative, because if it had a negative in front, it'd look like that, but it doesn't. This one shoots upward, so that's pretty good. This one goes downward again, or this one plateaus out. It's flat, so that one's bad. This one's shooting downward again. It's not a negative graph, so it can't be this one. So the only possible option is C. F of x 1/4 x. You could do the same thing here. Anything we plug in for x, if we plug in x equals 0, it becomes it just becomes 1. Let's say y equals 1, right? Because this is just saying y equals whatever. If we plug in x equals 1, y equals 1/4. So you could see already that this number is already getting smaller because it's going from 1 to 0.25 when we are increasing in x. But we could show it the next one, x equals 2. That becomes y, if this is 2, then you distribute the 2 on top and bottom, so it becomes 2 over here, which is 1/16. Again, 1/16 is smaller than 1/4, and then you could keep going, 1/64, blah, blah, blah. So the number's getting smaller. However, I think you might be able to see that the number's not becoming negative. It's just becoming smaller and smaller. So therefore, the graph is going to look something like this, where it's going to plateau towards 0. But it's never going to cross this this x-axis, but it's going to keep getting closer and closer. So which one? Let me use red. Which graph mimics that sort of getting closer to the x-axis but doesn't reach it? This one. And I guess we could just look at it real quick. There you go. As you can see, it starts at 1 and it keeps getting smaller. It's saying 0 here, but it's just rounding down. Like if I go slower, it cuts off at 0.00001. But if you were to have more decimals, it keeps getting smaller and smaller. It's just that Desmos stops at 1, 2, 3, 4. Is that 5? Tens, hundreds, thousands, millions. Okay. It's just Desmos has a rounding off point right there. This one's another word problem with money. So I think we're going towards the end of your class. Yes. For these, I would say use the equations that's given to you. So it's A equals P 1 plus R over N T to the N. Okay. Where T is time, N is the number of periods that pass. P is your initial amount. One is one. R is your interest rate, and N is your amount of time. This N is the same as this N. All right. Not the biggest fan of the variables they use, but I think for like simple problems, I think they use this notation. But there's a financial engineering video on here that has slightly different numbers, but I think it's better to use whatever they give you because that's what you've learned. So we'll just use what they give you. So P's our initial amount, which we see here is 1,000. Is appreciated for 6 years, so that's our time T. In an account that earns 15% interest rate, that's our R. Compounded semi-annually, so that's the amount of times it happens, N. Semi-annually, semi means 2, so 2 annually, annually means year, so semi-annually means twice every year. And see here you said N equals 2. All right. Find the amount of money in the account at the end of the period. All right. So this is our P. Probably shouldn't write over it, but whatever. This is our T. This is our R. This is our N. And I believe that's all we need. To go from percent to decimal, you either multiply or divide by 100. So if I had 0.25, if I want to turn that to a percentage, I multiply by 100, so that's 25%. If I have something like right here, 15%, if I want it in a decimal, I divide by 100, which is 0.15. Okay, so I just plug in everything. A is our future amount, 1,000 is our initial, 1 plus our interest rate of 15%, so it's going to be 0.15 because we want it in a decimal, not a percentage. N is semi-annually, so it happens twice every year, so it's 2 because we're doing this in terms of years. But you probably don't have to worry about that. I'll just let you know that. And then T is 6 years, so 6. And then it's T times N. It happens twice, so it'll be 2. You plug that into your calculator, and I'm assuming you get this. I'm not checking. Initial investment of $12.90 is appreciated for 13 years in an account that earns 3% interest compounded continuously. Find the amount of money in the account at the end of the period. So continuously gives you a clue that this is going to be using this other money equation they give you, which is A equals P E to the RT. Right? When it says continuously, use this one. If they give you a compounded and then like a year time, like they say monthly, then N is going to be 12 because there's 12 months in a year. If they say, I don't know, every quarter annually, a quarter is 25%, so it's every 4 if it said quarter annually. But if it says continuously, then you're going to use this equation, which our P is our initial investment of $12.90. E is a number that you plug into your calculator. It's E. T is 13 years. Our interest rate is 3%. 3 divided by 100 is 0.03. And then that's it. So it's going to be A equals 1290 times E, interest rate of 0.03, 0.03 times 13. Plug it into your calculator, and I'm assuming you get this. All right, solve the equation 25 or 27x to the third. Why am I drawing the blank here? Okay. For this one, I mean, I could just eyeball it, if I'm being honest. But if you want to write it out, you have to see some things here, which might be a bit hard, but, you know, tough titties. You have to notice that 27 is a multiple of 3. Or 3 is a multiple of 27. So 27 is the same thing as saying 3 cubed, right? Because 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. So you could rewrite 27x as 3 cubed times x, right? Because 3 cubed is 27, and then the x stays up. So if you notice that, 3 to the 3x, and then this is still equal to 3. Remember, if it's just a number by itself, it's technically to the 1, right? You just don't write it because it's redundant, but this is to the 1. So since the bases are the same, that means we could just solve for the exponents and set them equal to each other. So it's going to be 3x equals 1, which, I mean, you divide by 3 on both sides, x equals 1/3, and that would be your answer. Right here. Again, if I had something like, let me think. If I had 16 to the x equals 2, 2, 4, is that right? 2, 4, 8, 16, yeah. You would have to notice that 16, or 2 is a multiple of 16, so you could rewrite this as 2 to the 4th, because that's equal to 16, and then times x equals 2, and remember this is 2 to the 1, and so since the bases are the same, you could set the exponents equal to each other, solve for x, so 4x equals 1, x equals 1/4. Oh, we're doing this one, so. Why is this page so empty? Oh my. Now, let's just think. Well, first of all, I mean, I could see the answer right there, right? But first thing you could notice is that this is not a fraction, and this one is a fraction. And so anything that this exponent has to be, it has to be negative, because let's say this is, well, I could see the background. What? Okay. Is one of them open? Yeah, one of them is open. Is 2 of them open? 2 of them are open. 3 of them are open. How many are open? Okay, don't matter. So if I had like 1/2, let me use this example again. Right? This x has to be negative because we want this 2 to be on top, right? So it has to be the opposite of 1 over 2, which is 2. So if I multiply, if this x becomes -4, that means -4 is going to be right here, -4 is right here. 1 to anything is going to be 1, so that doesn't really matter. And 1 over 2 to the 1 over 2 to the -4 is just going to be the opposite. So it's just going to be 2 to the 4 equals 16, which is true. Right? So, just off rip, we could see that the number is going to be a negative number. Because this doesn't have anything above it, and this one does. So this must be a negative number to like make it flip so that the 6 is on top. All right. What else? I mean, I'm assuming 6 to the 4th is 1296, if I had to guess. It is. Psh, I don't know. I mean, I guess you could kind of just guess that. I don't know. Okay, so this is one of those educated guesses. We know it's not C or D because it has to be negative, right? And we know it can't be A because if it was okay, let's say this. We already know it's going to be negative, right? So we could already assume it's going to be 6x equals 1290. That's a 9. It's going to be 1296, right? So we could kind of just get rid of this part altogether because we know the answer is going to be negative anyway. And we know it can't be A because 6 to the 1/4 is a root function, right? And that's going to make 6 smaller. And so, but if it was 6 to the -4, or not negative, because we already know it's, get rid of that then. We know it's going to be an exponent because it's going to make the number bigger. So this is going to be an educated guess here. Or I guess it's not an educated guess because we know it can't be C, D, or A. So that's just what's left. Again, the reasoning is it can't be a positive number, it has to be negative, and it can't be 1/4 because 1/4 would shrink the number, not increase it. So we're going with B. Dig dang, another one of these. Okay. 25 times 25 is 625. I just know that off rip, so cool. This is 5 to the -x. So we could already say this is 5 to the x equals 1 over 625. So we know this number can't be negative because it's already at the bottom and this is already at the bottom. So it can't be 4, and that's the only one that's negative. Or it can't be B, that's the only one that's negative. It can't be C because it's going to make the number smaller at the bottom and not bigger because we need 625. So it can't be C. Same thing with D. The D is going to make it a root 5 of 125. It's going to make it the number smaller, not bigger. So the only like conceivable answer is 4, which 5 to the 4th is 625. So that does work. Logs. Log base 4 of x. Ooh my. For logs, let me just double check. I don't even know if I can. Can I do base logs? I don't even know if I can. Log. I got an. Oh, I have a log. Oh wait, I need a. Oops. From what I remember, log graphs tend to look like this, right? Where what would this look like? I don't know what I don't know what this look like, But typically it increase very slightly towards positive infinity in the x direction. So I mean, you can see here that it's just slowly getting higher and higher, but it's not like substantial. So I mean, just kind of freeballing it. Log graphs tend to look like this, which the only one that looks like this is A. So that's just kind of a good rule of thumb. It's not. I don't think it's always true, but it is a good idea to have. If it was negative, it would do the opposite, right? Because when you make something negative, it flips it over the x-axis, right? Which is C in this case, but this one's a positive log graph. Positive log graphs tend to look like, again, that. So kind of I just go to the next one. Log to the 1/4 x. I mean, this one says D. It has something to do with the base that I don't particularly recall. Or did I lose it? I said, what, 1/4, right? I could write 2.25, it doesn't matter. Yeah. So, I wonder if... Oh, no, probably back up. Wasn't gonna be 0, right? Yeah. Two. 0.9. Yeah. Okay, another rule of logs. Let's make it 0.5. Yeah. Is that it depends on the base number you have right here. If it's 0, 1, if it's 0, I think it's undefined. I might be wrong about that. But if it's 1, it's 0, so it doesn't matter. So if the base number here is greater than 1, you're going to get that classic graph that looks like that. If the base number is less than 1, so if you have like a fraction, it's going to be looking like this. It's going to be going downward. If it's above 1, but it's negative, then it's going to be looking like this one. Same thing, if it's below 1 and it's negative, it's going to be looking like this one, right? So if I come back to here and I put a negative in front of it, it's probably going to flip over the x-axis. Bam. Like it's the green graph. So if I put a negative in front of it, it flips over the x-axis. So that being said, it's below 1. 1/4 is lower than 1. So it's going to be looking like this. So which one looks like that? It can't be B because that's the classic graph. Can't be C because I don't know what that is. It's either A or D. And then A, you can see this one, it never crosses the x-axis, right? Because then you would see like a line that goes this way. Right? And the classic graph crosses over. Same thing with the smaller one. It also crosses over just in past it. So the only one that actually crosses that x-axis is this one, D. Okay, where is the next? Oh, there's more logs. Okay. If 3,500 is invested in an account that pays interest continuously, compounded continuously, so we're using A equals PE to the RT, just from that continuously word. How long would it take to grow to 7,000 at 5% interest? Round to the nearest tenth. So, this one's saying find how long, right? How long is the time, t. So we're looking for this t. No, my calculator said, not yours. I was gonna say and solve it, but you don't have that. So what we're gonna do here, this is a log problem. Ugh. I think it'd be better if you don't plug in the numbers now, simply because it's gonna look a bit weird and it's gonna look a little longer horizontally if you plug in the numbers now. But we have our A, which is 7,000. We have our interest rate R, which is 0.05. We have our initial P, which is 3,500, and we're looking for T. So I think we should keep it in this format for now and just solve it algebraically without the numbers because it might be easier to look at. So with a rule of E in logs is that anything to the natural log of E becomes 1. Similarly, if I were to take, no, that's not right. If I had log, yeah. If I were to take a natural log and an e to the natural log, so this is the exponent, and then let's say this is x, this just becomes x. So let me do that. I think I could just write it. ln of, do I have e here? No, I don't. Where's e? So ln of e is 1 because log base e is natural log. I don't know if you need to know that, but... And if I were to take an e to the natural log of x, it doesn't show the equal sign, but this is an x graph. That's above, it doesn't go past it because it would be undefined if it went past that, but you could just keep it as x. So if I had e to the natural log of, nope, that's what I want, 5, it's just gonna spit out 5. Same thing if I had e here to the 5th, it's gonna be 5. So that's how we're going to deal with this, is that we're going to apply logs and e's to this. I put e, it should be e to the 1, that equals 1. So if it was e to the 10, natural log of e to the 10 is going to equal 10. If it was e to the 5x minus 10, for whatever reason, this equals 5x minus 10. It's one of those kooky, weird things in math. It's not weird, but whatever. So we want this t brought down because it's an exponent right now. We know that this is an e to the rt. So based off that, we could take a natural log of both sides to bring it down. So let's do that. So multiply natural log on both sides. It's going to be natural log of a equals natural log of p okay, that's another rule of natural logs. So, another rule of logs is that if you're multiplying or let me write it like this. I was wrong anyway. if natural log A times B, and this is all inside the natural log, it's the same thing as saying natural log A plus natural log B. Same thing for, this is all logs, not just natural log. Same thing if I had natural log of A over B, this would equal natural log A minus natural log B. That's why I write it like this in this format, because let me do purple, natural log of P e to the RT. P and E are being multiplied together, so you can rewrite this as natural log P plus natural log e to the RT. That's where this separation comes from. And the natural log of A is that. Okay. So, next step is to just bring the RT down, because natural log of E to anything just brings the X down. So this will be natural log of A equals natural log of P plus RT. And then we could just solve for T here. It's going to be natural log of A minus natural log of P, which is, we could use that rule to change it to a different thing. And then it's going to be equal to RT. I'm going to rewrite this one as natural log A over P equals RT. And then bring T by itself, you divide by R. And then you plug in everything we know. We know P is 3,500. We know R is 0.05, and we know A is 7,000. You plug that in your calculator, and it spits out what I assume is 13.9. What up?
So,
What are you waiting on?
nothing. Is this the video?
This is the video.
What do you think's gonna be done?
Yeah, I don't know.
Type. Thanks.
2,500 is invested in an account that pays interest compounded continuously. Is this gonna be another log one? Whatever. So we know we're using A equals P to the E the RT. Is this the same problem? No, it's not. I mean, it's another log one, so it's good practice. How long would it take to grow 5,000? So this is going to be our P. This is our A. This is our R. How long is our T? So we're solving for T again. So this time I'm just going to kind of speed run it a bit, because the last one I kind of took a little bit slow. So we take a natural log of both sides. It's going to be natural log of A equals natural log of P plus natural log of E to the RT, which of course just becomes RT. Natural log of A equals natural log of P plus RT. Solve for T, you get natural log of A. Let me do this. A over P over R equals T. And I guess we could just plug this in to Desmos just to double check we're doing it right. So this is going to be, I already forgot what it was, 5,000 over 2,500? 5,000 over 2,500 divided by R, which is 0.05. So it's 13.86, which rounds up to 13.9. Use a graphing calculator to solve the equation. Wait, you're allowed graphing calculators? Well, okay, I guess 3x equals 12. I don't know how you would solve this on your graphing calculator, but if I put in the Desmos, I could see that x is going to be equal to 2.26, which is right here. Wait, if you are using a calculator, you're looking for when the graph crosses the x-axis, which it crosses at 2.26 here, so, and it crosses nowhere else, so this is our answer. 1.18x equals 4. 1.18 to the x minus 4. This one crosses at 8.375, which is 8.38. Now you might be wondering why I'm graphing 3x minus 12, or in this one I'm using 1.18x minus 4. This one, if you want to graph it as a line, you have to set this one equal to 0. So I bring the 12 over here, which is subtract both 12 on both sides, so this is equal to 0. This is equal to 0. If you were to bring the 4 on this side, it's the same thing. 12, same thing, right? If the question was like 25x squared for whatever reason equals negative 12, if I want to bring it on the other side, it's going to be 25x squared plus 12 equals 0, and I graph that and see where the line crosses the x-axis. Rewrite the expression as a single logarithm. Okay. This is... Ooh, I don't remember what that means. I mean, here, right? Diddly 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 doo, diddly 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 doo. Let me look at this one real quick. Okay. For logs, there's a lot of rule with logs. I suppose I could write the ones I do remember. For log, or natural log, log A plus log B equals log A over B. I already messed up. It's going to be log... Oh my, I keep messing up. A times B, that's what it is. For log A minus log B, it's going to be the one I said, which is log A over B. For log, I'm going to use x to the A. X to the A. Oh, by the way, this only works if they have the same base. So n, which I doubt they're going to switch it up on you. So, I mean, I guess we'll see. For log x to the A, it's going to be A log x, which you can see kind of right here. I think that is all of them. Well, not all of them, but the ones you worry about, because I could see what we're doing here. But with the bases, this has a base of m and m, so you could do all the identities I just showed. So we have a 2 in front, so we could make that an exponent of q. Same thing with the 9, we can make that an exponent of here. So let me do this. Okay, we're just gonna have that now. I'm gonna use red. Nope, that's not, I don't want you. So we could rewrite this, bringing the exponents up as log. I'm gonna ignore the base m because they're both m, so it's kind of like they all have m, so it's kind of redundant to write it. So whatever. So log, this is q squared minus log z squared times 9. Because you're multiplying this 9 with this 2, so that becomes 18. And this is based off this rule right here, that if you have a number in the front, it could become the exponent of the variable inside the log. So that's what we're doing here. We're bringing the 2 to the exponent of this q, and this 9 to the exponent of this z. And then I'm just going to rewrite this as 18. All right, so what's the next rule we could do? Well, there's a minus sign here, and they have the same base of m, so we could do this one right here. So it's going to be log of q squared over z to the 18th. And I believe that's all we could do to this, and this has a base of m, which is this one. We already did this one, but it has an exponent here. We could bring that in front, so it becomes this one. Log of 100. Now this one's a bit weird. This one, it's better to look at the answers and see which one makes sense. So I guess we could do... we know it's A, I see it here, but we could start from D and work our way upwards instead. So this one is saying we could bring the 2 in front, or not in front, but up. So it's going to be log of 2 squared, which is 4, minus log of 5 squared, which is 25, which is, of course, log of 4 over 25, which is not 100, so it can't be D. So let's do 3. It's saying log of 2 cubed, which is 2, 4, 8. So log of 8 plus log of 5 squared, which is 25. And then since these are adding, you multiply these together. 8 times 25 is not 100. That's 200, so it can't be this one. When multiplying logs, it's completely different, so you might want to just skip over that one. So let's go to A next, which is log of 2 squared, which is 4, so log of 4, plus log of 5 squared, which is 25, log of 25. These are adding, so you multiply their numbers inside, which is 4 times 25, which is 100. So this equals a log of 100, which is our answer, based off, again, these identities here. You might question why didn't I use... Well, I did use 2 of the identities here, but you might question the whole ln of e to the r equals r. Depending on the base changes the answer. I don't think you have to worry about this principle unless you're dealing with natural log, but it applies to all logs. So if it was log m to the m r, this would equal r, because natural log has a base of e. So this is essentially saying log of e to the r equals r. That's what this is. And this is similar to that, but again, the only time you really have to worry about that is when you're dealing with natural logs and not regular logs. So I don't think you have to worry about this small rant I just went on. Rewrite the expression as a sum or difference of logarithms or multiples of logarithms. Okay. Well, looking at the answers, we're not multiplying logs together. We're adding or subtracting, so immediately get rid of C. So we can either we could work our way from the answers again. We could just do this one and then do this one and then do this one. Is that the better option? I think we could rework from this. Oh, we can, but so we seen x to the 6th and y to the 5th here. We can ignore this 4 right now. I'm just gonna write log. So they're being multiplying, so we can add them together. So this is the same as saying log. And then the order of operation does matter because 4 is being divided by everything and not just one number. So that means the negative has to go in the back. Or does it matter? Oh, no, it doesn't even matter. This could go in the front, doesn't matter. Alright, yeah, okay, if it doesn't matter, then I could just do whatever I want. So let's just start with this then. So it's gonna be log x to the 6th plus log y to the 5th. And then we could do this one. This one's dividing, so it has to be minus. So it's going to be log to the 4. Right? And then remember, on the other rule, we could bring the exponent to the front. This one doesn't have an exponent, but I mean, you can put 1 in front if you want. So it becomes 6 log x to the 6, or nope, 6 log x plus 5 log y minus log 4, which the only one that matches this one would be A. What? Use a calculator and the best chance for him to find the logarithm to 4 decimal places. What's the best chance for him? I'm just going to plug this in. What are you talking about? I think it was log base 2. Wherever this log is. Base 2, and it was like 46.02. So 5.52. I don't know. Solve the system by addition. Yeah, these are the last problems. So addition is that you're adding both these equations together, like this. Essentially, this is on top, this is on bottom, and you're adding them together. Yeah. Substitution is that with the first equation, you're solving for one of the variables, x or y, and then once you solve for that x or y, you plug it into one of the other ones at the bottom. This one just says solve the system. I think the easiest one to do is by addition, but when that fails, then the next best one would be substitution. Which I would say for this one right here, it'd probably be yet best to do substitution. Okay, so let us leave. So for addition, we typically want to cancel out one of the, or not cancel out, we want to zero out one of the variables, so we're just left with 1. The way we do that is we multiply one of the equations by a whole number, right? And so for simplicity's sake, let's just multiply this top equation first. And if we want to get rid of this negative 3x here, then we have to multiply this top equation by positive 3. So I'm just going to right here, and this becomes, I'll use blue for this, 3x plus 9y equals negative 3. This bottom is going to be negative 3x plus 2y equals 14. And we're still adding this equation. All right, now when we add both equations together, we have this positive 3x and this negative 3x. They cancel each other out because 3x minus 3x is 0. And now 9y plus 2y, that's going to be 11y. 0. And then negative 3 plus 14 is going to be 11. So we're left with 11y equals 11, which of course is going to be equal to 1 because you divide by y on both sides and you get 1. So that means if y equals 1, we could plug this back into our original equation right here. X plus 3y equals negative 1. And if y equals 1, that means this is x plus 3 equals negative 1, which x equals negative 4. They don't have a answer, so this is our x, this is our y. That's how you do by addition. You could also, if you want, change the bottom equation to match, to cancel something on top, but I'm not going to do it. So for substitution, you solve for one of the variables on top or the bottom, and then you plug it into the other equation. So let's do this one again, and let's solve for x. So this first one is be x plus 6y equals 18. Solving for x, we get x equals 18 minus 6y. All right, and then we're going to take this second equation, this one, and we're going to put it right here. So it's going to be 2x plus 6y equals 12. And we know from here that x equals 18 minus 6y, so we could plug that into there. So it would be 2, I already forgot it, 18 minus 6y. Plus 6y. This is going to be 36 minus 12y plus 6y equals 12. This is 36 minus 6y equals 12. Solving for y, you get, move over here. 12 minus 36 is 26, 24. Y is going to be equal to 4. And if y equals 4, then we could plug back into here. 6 times 4 is 24. That means x has to be negative. So that means x equals negative 6. I hope I'm right. I guess I could check right now, right? Negative 6, 4. Negative 4, 1. Yeah. And then for this last one, excluding the ones I skipped. X squared plus y squared equals 113. X minus 1 equals 1. I think it's easier to just substitute, solve for one of these at the bottom, and then substitute. So we'll solve for x, and then substitute that x into this one. So x is going to be equal to 1 plus y from this equation, and then we can plug that into this one. So it's going to be, I'm just going to do it already, so I'm going to do 1 plus y squared plus y squared equals 113. This is a quadratic. I didn't even realize. This is going to be y squared. I might as well write it, right? This is the same thing as saying y plus 1 plus y squared equals 113. This is going to be y squared plus 2y plus 1 plus y squared equals 113. Oh my glob. 2y squared plus 2y plus 1 equals 113. Move 113 to the other side, so it's going to be 2y squared plus 2y minus 112 equals 0. Plug that into the quadratic equation to solve for y. Which apparently it's -7, -887. Oh, you know what? It's probably plus or minus 7 and 8. Yeah. Do I want to do that? Not really. I'm not in the mood. Okay, where are the ones I skipped? I might not even do them, if I'm being honest. Where are they? Find the vertex of the parabola and synthetic division of... Okay, so these... Okay, I'm not going to do these. I won't do these because the other... Poop. I don't even know which one I'm on. The other video has a lot better explanation of me doing this, and this video is already probably over 2 hours. Same thing with this one. It has an example of this, so I'm not going to do that. I'm just going to double check the rest of them have examples before I just go on and quit. Find the inverse of the function. So this one doesn't, so I have to do this one. What about this one? That one's not one. So this one also has a better explanation on the other video, so I'll just leave it up to that. Oh, there's so much. This one I'm pretty sure also has a small portion on it, so I'm not going to do that. And then the rest of them, yada yada. I think it's this one. Okay. I'm just gonna erase this then. It's gonna be a white back, or you know, I could just charcoal this. What? Give me one moment, because I apparently forgot how to do an inverse of a function. I'm gonna look it up. Wait, what? I'm just solving for y? Is that it? Oh no, I'm solving for x? Yeah. Are you? What a. So. Okay. That is that answer. Look at that. So for the inverse of a function, you're given f of x, which is again y. So write it that way. You are solving for this x, right? So it's going to be y plus 6 equals 8x. And then divide by 8 on both sides, it's going to be y plus 6 over 8 equals x. And then you look over here and you're like, well, there's an x on this one, and there's a y here, and this says f inverse of f of x, and this is x. This next trick is just change this y to the x and change this to inverse of f of x. That's all you're doing. And that's the answer. There you go. And so we're doing the same thing here. It's going to be y equals 5x cubed minus 3. We're solving for this x. So it's going to be y plus 3 equals 5x cubed. Divided by 5 on both sides would be y plus 3 over 5 equals x cubed. And then get rid of the cubed. You take a cube root. So it's going to be and then we switch the y and x for their respective things. So it's going to be cube root x plus 3 over 5 equals inverse f of x, which is this one. All right, I think that's it. The other ones I skipped should be on the other videos, and they're probably better explained. This one is very long, so good luck, all that. Goodbye.